Today, let's look at this elementary question regarding inequality. Suppose 0 less than b less than or equals to a. But also prove that a plus b over 2 minus square root of ab is in between a minus b squared over 8a and a minus b squared over 8b. Please give it a try before you look at the answer. For those studying inequality, it is well known that a plus b over 2 is greater than or equals to square root of ab. This is an elementary result regarding AM/GM inequality. So how to prove that? Since 0 less than b less than or equals to a, it means that both ab are positive. With this, square root of a, square root of b are real numbers. So square of difference of two real numbers is greater than or equals to 0. Expand the left hand side, we have b plus a minus 2 square b square a greater than or equals to 0, which means that a plus b is greater than or equals to 2 square root ab. And therefore, a plus b over 2 is greater than or equals to square root of ab. In fact, for today's problem, we do not need to prove a plus b over 2 greater than or equals to square root ab. It's just that we want to know what is the possible range for this difference. In order to do that, we consider a plus b over 2 minus square root of ab. We can treat it as a plus b over 2 minus square root of ab over 1. Now we multiply both numerator and denominator by the conjugate, which is a plus b over 2 plus square root of ab. For the numerator, it is of the form x minus y, x plus y. So it will be x squared minus y squared. For the numerator, it is a plus b over 2 squared minus ab. For denominator, it remains the same. And now we multiply both numerator and denominator by 4. And this gives a plus b squared minus 4ab over double of a plus b plus 4 times square root of ab. For the numerator, it is equals to a minus b squared. And for denominator, it remains the same. Since 0 is less than b less than equals to a, we know that a plus b will be less than equals to a plus a and greater than b plus b, which means that a plus b is in between 2b and 2a. So double of a plus b will be in between 4b and 4a. Now we obtain the first inequality that we want. Now consider AB. Again, since 0 less than b less than equals to a, AB is less than or equals to a times a and greater than or equals to b times b. So AB is in between b squared and a squared. And so square root of AB is less than or equals to square root of a squared, which is equal to modulus a. And since a is positive, modulus a equals a. Likewise, square root of ab greater than or equals to square root of b squared, which is equals to modulus b. And again, b is positive, square root of b is b. And now we know that 4 times square root of ab is in between 4b and 4a. And this is the second inequality that we have. From these two inequalities, the sum is double of a plus b plus 4 square root ab and is in between 8b and 8a. And the reciprocal is in between 1 over 8a and 1 over 8b. So the expression that we want is actually in between a minus b squared over 8a and a minus b squared over 8b. And hence, we prove the inequality. Hope that you have learned something new today and enjoyed this video. This is the end of today's discussion, and I'll see you again next time. Bye-bye.